Hello there, and welcome to the Inner Space of the Heart class. I'm Idaho, and I'm going to be your host through this video. Okay, I'm an undergraduate of public health at BYU, Idaho, and in this video I'm going to be sharing you some knowledge I have about the heart. Okay, these are the subjects we are going to be discussing throughout the class. You can stop the video and check each one before you start the discussion. Okay, so first let's deal with the misconceptions of the heart. The first misconception people have is the shape of the heart. Most people imagine the heart is this cute, when I actually think it's even cuter. Okay, this is a sliced image of the heart, and that's what I'm going to be using throughout the lesson today. Okay, the second misconception are the sides of the heart. Okay, this is the right side of the heart, and this is going to be the left side of the heart. But you're probably saying something is wrong, Dewey. Because when we look at the mirror, for example, we say, hey, this is our right, and the mirror is lifting the arm on our right. And we say, this is our left, and we see that the mirror is also lifting the arm on our left. Okay, so that technically saying, whenever we see something in front of us, like these two balls, you would probably say the red ball is in the right, and the green ball is on the left. So this must be the right side of the heart, and this the left, right, Dewey, and not the other way around. And I would say that would probably be right. Okay, if in bio we were to consider the mirror perspective. Okay, however, in biology we use the subject's perspective. Okay, yes, we use the subject's perspective. And what is that? Let's say, for example, that you are walking down the street and you meet a friend of yours. Okay, you decide to say hello to this friend by lifting your right arm, okay, and waving at your friend. Let's say that by coincidence he also decides to do the same by lifting his right hand, his right arm. Okay, would he lift the arm on the same side as you? Would that be his right arm, like the mirror, or would he lift the cross arm, different than the mirror? And yes, the cross arm. Okay, why the cross arm? When two people are facing each other, as they lift the arm, for example, and the other one does the same, although they are lifting arms in different positions, opposite to each other, they are still lifting their right arm. You see that our left is in front of the person's right, and this opposition, this perspective, is what we use in biology to name the sides of the heart. That's why it's switched. Okay, and this is the rotation. Okay, so whenever you are facing one direction, like in this example, the guy is upwards and he wants to go downwards. Okay, as he takes the first step to turning downward, he's taking his right with him, and then he completes his turn, and he takes the right once again, thus ending up on a cross side from us. That's why we say, that's why I said cross arm, because with this motion, and the sides are switched, left in front of right and vice versa. Okay, and he is using this cross siding. We just consider this left and right of ours, and you see how it's going to be the opposite, right and left of the persons. Okay, so remember, when you're giving sides, this is the left side and this is the right side, even though it's opposite to what we see is opposite to us. Okay, Now that you know the size of the heart, let's learn its chambers. The bottom ones, these two bottom ones here are the ventricles. The two top ones are the atria, okay, or atrium. Each one is an atrium, okay. The valves, there are two valves separating the atria and the ventricles, hence atrioventricular valves, okay, AV valves. You have one with three flaps. Each cuspid is a flap, so tricuspid valve, okay. Then you have the bicuspid valve, because there's only two flaps, as you can see in the image on top of the screen, or also known as mitral valve. Okay, there are two valves that separate the ventricle and the phloem, which are the pulmonary semilunar valve and the aortic semilunar valves, okay. And then, now that we know the valves and the chambers of the heart, let's see the conductors. One little thing I have to remind you before we begin is this. Some people misconcept, I didn't put in the misconception part, but people misconcept that veins are tubes with carbon dioxide blood, okay? And arteries are oxygen blood, okay? That's wrong, okay? Veins is every tube taking blood into the heart, and artery is any tube taking blood away from the heart. So you will see right now that there's even a vein and an artery for the carbonated blood, and a vein and an artery for the oxygenated blood, okay? So now the poor oxygen blood, you have the blood coming in through the superior and inferior vena cavas, okay, and it goes out through the pulmonary artery, alright? Then you have blood rich in oxygen coming in from the pulmonary veins, and they are leaving through the aorta to the body and tissues, okay? Now, since circulation is a closed circuit, has no beginning, no end, I could start anywhere I wanted, so I'm going to start with the rich oxygen blood, okay? First, blood comes from the lungs and fills the atrium. The atrium squeezes the blood into the ventricle through a process we call systole, and again through systole, the ventricle squeezes the blood into the aorta to go to the organs and tissues, okay? Now the body and the tissues use the blood, okay, then the blood has to come back to the heart, so low oxygenated blood enters through the superior and inferior vena cava, fills the atrium. The atrium squeezes the blood into the ventricle. The ventricle then squeezes the blood into the pulmonary artery, okay? Nevertheless, I have to remember you guys that these actions are coupled, okay? I show them separate, but they are coupled, so the atria systole together as do the ventricles, okay? So let's have a closer look to how it works. You can see two beams there, okay? The yellow one, the top one, is the sinoatrial node, and the green one is the atrioventricular node, okay? You see, once the sinoatrial node fires a signal, he fires a signal to the two top chambers, okay, the atria, and the atrioventricular node. But due to a speed differential, the sinoatrial node will fire the ventricles a little bit later, okay? And it's interesting to notice this, because that's exactly the time that the atria, this speed differential is exactly the time the atria have to squeeze the blood into the ventricles, okay? So as you see, the blood comes from the body and the lungs. The sinoatrial node sparks the signal. The valves open, the blood is squeezed into the ventricles, okay? Now the atrioventricular node receives the sign. The valves are shut. It orders the ventricles to squeeze, and the blood is squeezed through the semi-lunar valves into the lungs and organs and tissues, okay? I don't know if I said in the video already, but you have to remember that the two valves, the tricuspid and bicuspid, open and close through muscle change, okay, muscle movement. These two semilunar here, they work through pressure, okay. The squeezing of the ventricle increases the pressure to the point that they open and the blood shoots up the artery and vein, okay. Now here's the stopped image. You guys can stop the video now and see which blood goes where. You know, I change color so you guys can follow up the process more clearly, okay. And then once you're through, you can push play again and continue the video, okay. Now it's a little dramatic scene there. The blood comes from the body and from the lungs, fill the atria, the sinoatrial node sparks, the valves open, the atria squeeze the blood into the ventricle, the valves close, the atrioventricular node sparks the signal to the ventricles, here you squeeze the blood and the blood shoots out to the artery and vein, okay? So that's how it works in real life, okay? So you see the coupled action there, and this starts all over again at a rate of 8 cycles per minute, which are those 80 beats per minute the heart does, okay. And when you want to see if you're alive or if you're sick, if you're having any problem, or when you're doing some exercise, you put your fingers to your throat to see your heart beating, okay. That's what you are trying to see. This process here just explained to you, okay. So thank you guys, that's it for now. This is a cool project, I hope you guys enjoyed. Sorry if I made a little mistake, okay. I'm using all my knowledge, all the knowledge I gained this past 2 weeks from the modules, books, and online material from college, okay. I also didn't prepare any scripts beforehand, so I'm doing really from my heart, okay. So if there's another mistake, this video is in my YouTube channel. You can just leave your comment there, okay. Probably we won't correct the video, but if the mistake is corrected on the comments, anybody who is using this class to learn can see it and can know what's correct. Okay guys, thank you so much. See you later. Bye bye.